Hey everyone, Steve here again with another random video. On the screen now is my personal laptop, the Lenovo Ideapad Flex 14 that I've been using for almost the past year. For the price that I got, it's a decent laptop. It has a Ryzen processor equivalent to an 8th gen Intel i5 chip, okay battery life from what I've experienced, a 1080p touchscreen with pen support, and expandable memory and storage. One problem that I've noticed in quiet settings was the noise the laptop's fans produce when it's idle or handling low-level applications, like a couple browser tabs. As I said, this is only noticeable in a quiet room or environment, so it's not the end of the world. I'm fine with the fan noise when there are multiple tasks going on, whether it's for performing casual work or for a light gaming session. But it started to become a bother to me that I wanted to try to do something about it. In the UEFI settings, Lenovo has some features, but nothing robust. One thing I had at my disposal at the time was some extra liquid metal from a previous project with my Hackintosh. Since I wasn't planning on doing anything else with it, I decided to apply it to my laptop's CPU die to see if that would cause the laptop to not trigger the fan as much. Here, you'll see my process and how I applied the liquid metal and measured the CPU temps and fan noise. As always, I'll put in the description the products and tools I used in this video if you want to attempt this on your own laptop. Before continuing with the video, please take a moment at the end of the video to like or dislike it. If you like the content I put on this channel, consider subscribing and clicking on the bell icon to keep up on future videos. I don't always release videos in a timely manner, but it'll let me know if viewers enjoy my videos enough to allow me to continue making them. Thank you. And with that out of the way, let's start with opening up the laptop. On the bottom of the laptop are 10 screws that need to be taken out with a Torx T4 bit. The bottom cover won't just come off after that due to some plastic clips. I took my plastic pick to go around the laptop's edges, but something like a credit card might suffice. With the bottom cover off, we have the exposed motherboard. For safety reasons, I unplugged the battery's connection to the board to prevent any damage or accidental startup. To remove the heatsink on the board, the 3 screws to remove it are located here using a Phillips PH1 bit. In the video, you'll see me remove the fans as well, but I found out during disassembly that they are not attached to the heatsink. With the heatsink removed, I went ahead and cleaned off the original thermal paste on the processor die with dry cotton swabs and swabs soaked in 99% isopropyl alcohol. I also used a pick to gently get some of the paste stuck between some of the capacitors and resistors. When that was done, I also cleaned off the heatsink using swabs and alcohol. Since the liquid metal can potentially short the capacitors and resistors around the die, I need to protect them before applying the liquid metal. I used 2 layers of protection, the first layer with silicone conformal coating and a second layer with Kapton tape. If using conformal coating from a can like me, make sure to spray it outside because the fumes it gives off are dangerous for inhalation. I sprayed some coating onto a cotton swab and applied it to everything except the die itself. After applying, I let it dry for 20 minutes and applied 2 more coats after that. When the 3rd coat was dry, I applied the Kapton tape. I only used a couple layers to protect the surface and tried to smooth out any air bubbles with my spudger. It doesn't have to look perfect since the heatsink will sit on top of it. Now that the surrounding area is protected, I could apply the actual liquid metal. Pulling out the applicator and screwing on the tip, I grabbed a paper plate to initially squeeze out a drop. I used the tip of the applicator to transfer a drop over to the die. Using one of the included cotton swabs, I spread the drop around on the die and tried to make it even. Only a thin layer needs to be on there, nothing excessive. The excess was placed on the heatsink afterward. When I was satisfied with how the application looked, I reapplied and secured the heatsink, reattached the battery, and closed the bottom of the laptop. I turned on the laptop, and it ran without any problems or any thermal shutdowns. From this, at least I know the application of the new thermal paste was a success. From here, I would move on to testing. Before performing the paste swap, I had to figure out a way to compare the two thermal solutions. My main goal for this liquid metal experiment was to see if there was any significant improvement to the fan noise when the laptop was on idle and or running a simple program like a browser. My optional goal was to see if it improves the temps of the three settings in the UEFI settings. As I showed earlier in the video, Lenovo offers the user some ability to adjust the system performance, which includes the fans on the laptop, but only using these three settings: quiet, performance, and intelligent. I have been using the silent setting since I've owned the device. In order to get an accurate comparison, I had to test the laptop under different test scenarios and also test these scenarios using different performance modes. For test scenarios, obviously the first two would be an idle run and when the laptop was running a normal workload of a browser and application, in this case PowerShell ISE. I also went ahead and tested two other scenarios: a gaming session of Rocket League on normal settings since this laptop isn't a gaming beast, and a CPU intensive session of converting a 1080p video with the video conversion tool Handbrake. I wasn't expecting too much from either of these tests, but out of curiosity I wanted to see if there was an improvement. All scenarios will be run for 20 minutes for each setting, and afterwards 10 minutes to cool down and to change to the next system setting. The data measured from these scenarios would be the thermal temperatures and the fan noise. To measure the thermals on the device, I use Hardware Info's diagnostic software to collect that information. The software can log a bunch of information about the laptop over a user set period of time and puts it into a CSV file. As for measuring the sound, that was a little difficult. I would have liked to record the fan's RPM data instead of measuring sound. Unfortunately, on this laptop model, Lenovo doesn't allow users to view fan speed. Due to not owning any good audio measuring tools, the best I could come up with was using my phone and an app called SoundMeter. I kept the phone's mic near the fans of the laptop, but not in front of them since this would make all the results sound the same. I took note of the ambient sound of the room and the fan noise when the laptop was at certain CPU temps. With all that said, I performed the test with the standard thermal paste and after with the liquid metal. The results were kinda mixed. In terms of the fan noise between both the before and after tests, the noise stayed the same. To be fair, I wasn't expecting any change from this after my last experience with liquid metal. To have a change, I will have needed either better control over the fan speed or different fans in general. But I did get a good idea on the fan noise generated from all these tests. From these, I found if the CPU temps stayed between the mid 40 to 54 degrees Celsius, the fans would add between 2 to 5 dB to the ambient sound of the room. If the fans reached 55 to low 70 degrees, the fans would add 10 to 12 dB more noise to the room. This was the noise I was hearing when the PC was idle that caused me to do this whole video. Afterward, if the temps stay in the 70s or higher, the fan would go into overdrive mode and add around 15 dB or more noise to the room. I would only hear this when I was running a game or using the rendering software. For the temps themselves, I went ahead and placed them into tables. For both the idle and productivity tests, I included two categories: number of times the temps went above 55 and the longest period over 55. Basically, I want to keep track of how many times a fan got above its normal speed and the largest amount of time it stayed there. For idle, you'll notice some improvement on all settings with the exception to the performance setting. The biggest thing I found after applying liquid metal was if the CPU temp stayed lower than 39 degrees for a period of time, the fans would shut off and stay off until the temps reached 55. I was pretty surprised by this because I thought I had shorted something, but they did eventually power back on. For productivity, the silent setting actually got worse after the swap. For the other two settings, the average high and low temps stayed in the same range, but the fan stayed on a lot more for the performance mode. The setting that really came through from this test was the intelligence setting, since the fan was utilized half as many times compared to when it was using the old thermal paste. As for the gaming and rendering tests, neither of those improved temperature-wise after the swap, with the exception of silent mode for rendering. I did include the number of times the system went over 55 degrees because most of the time, the laptop stayed above 55 and eventually went above the 70 range to cause the fan to kick into a higher speed. The one thing that I should have included in the test, although I wasn't measuring it, was if there was a performance increase after the thermal paste swap. Going off the CSV files from the gaming test, for example, at both the coldest and hottest CPU temp, the CPU core speeds neither increased or decreased. Granted, I'm just going off a couple points on a file when I should have run some performance tests like Cinebench or something else. Overall, what was the takeaway from this project? In terms of the goals I set, I saw some fan noise improvement in my idle and basic task runs, and saw that the intelligence setting was the best setting to use on this laptop. Although for other settings, the fan was utilized more after the swap, so I see that as a negative. I would call this goal a wash. For my other optional goal, the thermals and noise on all three system settings pretty much stayed the same. It's unclear if there was a performance increase after the swap, but that was without additional testing. So I would say I failed at that goal. It looks like for now I'll have to live with the fan noise, but I thought it was an interesting experiment. If I had a laptop that had better heatsink and better fan control, I would try this project again, and also remember to take into account the CPU performance. So that'll do it for me in this video. This is Steve signing off, and stay safe everyone.